So now we have that the Laplace of f prime of t, and f prime is just that we are taking a derivative of f of t. This right here is s times the Laplace of its original minus the original function at 0, so f of 0. We can also figure out what's the Laplace of the second derivative of the function, because the second derivative is just like taking the derivative of the first derivative. So I can look at this as taking the Laplace of the first derivative of the first derivative. So the input here inside of this parenthesis here is f prime, okay? And if we match the formula, this right here will be s times the Laplace of whatever you enter right here, right? And in this case, it will be just f prime of t. And let me put that down into the bracket here. So f prime of t is here. And then we are subtracting whatever we have here. Notice that we are subtracting whatever we have here. We're plugging 0 into whatever we have here. So we are subtracting f prime of 0. And that's pretty much how we can reduce from the second derivative to the first derivative in terms of the Laplace transform. But then furthermore, because we already know that the Laplace of the first derivative, it's just this, right? The Laplace of f prime is just that. So let me kind of just box these two things. So I can substitute this into that. And I'm just going to write this down. So I have an s on the outside. Let me open the parentheses. So this word right here will be, let me see, s times the Laplace of the original function minus f of 0. Then on the very outside, we still have minus f prime of 0. Okay, so this is how we can reduce for Laplace transform of the second derivative into the Laplace of the first of the original. And of course, we have a parenthesis and an s on the outside. We can distribute, and we can get this as s squared Laplace times the Laplace transform of the original function minus s times f of 0, and then minus f prime of 0. So that's it. So this will be the formula that we're going to use very often to solve differential equations. Okay.